Hey guys, how's it going? We're going to start today. We're doing day 5 of Unit 1, and we're going to talk about using the microscope. So, on your home page here on Unit 1, you need to click on Lesson 1.06, Microscope Notes. And let me just see real quick if I can pull that up. So as you click on 1.06 microscope notes, it's going to bring up your notes for today. And of course, this is a Cami assignment. I feel like Cami just works a little bit better than Google Docs as far as you just being able to write directly on a PDF. So we're going to go through a microscope, and we're going to go through the parts of the microscope and use of the microscope. Now, microscopes are very important in biology, since some living things that we're looking at are very, very small. So we have to be able to use the microscope to see those things. And so I'm going to go to my other platform here. So this is just an increased version of your microscope. So as I go through these parts, if you will use your text box on Cami and type in the names of the microscope. The very first part that we're going to talk about is called the eyepiece or the ocular. So this is the part where you would place your eye up here at the top of the microscope. The ocular has a magnification of 10 times by itself. So if we were able to remove that ocular and look at an object, then that object would be magnified 10 times by itself, which is pretty amazing. If you think about microscopes, I should have, yeah. If you think about microscopes, some microscopes, especially the ones that we have at Cleveland High School, they can magnify up to 400 times. So that's looking at maybe something the size of a flea, and then looking at it 400 times its size. And so that would almost like it being the size of a lab table, which is kind of a crazy thing to think about. So the ocular or the eyepiece magnifies 10 times by itself. The next part is the body tube. That's the tube through which light travels up to your eye. And then you're able to see the image because light, and your light source is down here. Light is traveling up through the microscope. When you're carrying a microscope, you have to hold it by the arm. And also, I'm going to skip a few and down here by the base. So if you're ever carrying a microscope, you would carry it with two hands. You would put one hand on the arm, and then one hand supporting the microscope underneath the base. You would never want to swing a microscope just holding it with one hand or one arm, because then that could damage the microscope. You could actually hit it against the wall or the corner of a lab table. And microscopes are pretty expensive. They're about $300 to $500, depending on which microscope. Now, there are lots of other microscopes. There are scanning electron microscopes, transmission electron microscopes, but the ones that we use in class are called compound light microscope. Compound because you're actually looking through two lenses. You're looking through the ocular lens, and then you're going to look through another lens. So we'll get to those parts. These other lenses are called the objective. So go down one of those labels. And then the revolving nose piece is this portion that turns, and it holds all of these different objectives. So we have the revolving nose piece, just like your nose sticks off of your face. This revolving nose piece has these objectives, which stick off, or protrude from the microscope. Whenever you're using a microscope, you have to use a microscope slide. And the slide is a clear piece of glass. And then whatever you're looking at on the microscope, light has to be able to go through or travel through. So it's a very thin sliced organism or a thin slice of tissue that you'll be looking at underneath the microscope. Whenever you put a slide on the microscope, you're going to use the stage clips, these little silver metal clips here to secure that microscope slide, and you're going to place it on the stage. So this is the stage, this black platform here, and these are the stage clips, the silver metal clips that would hold that slide in place. Just like the stage at a theater, the stage is where the performance happens. Same thing here. The stage is where the action is happening. This is where you actually put your specimen so you can see it. Below the stage is called the diaphragm. The diaphragm opens and closes, and in some microscopes, you can manipulate that diaphragm to allow a great amount of light in or to allow just a little amount of light in. Some things show up with a small amount of light. Some things show up with a brighter light source. And here is the light source. Oops. Here is the light source right here. So the light source is at the bottom. We all have electric microscopes now. In the past, older microscopes used a mirror here, and that mirror would be used to direct the room or the ambient light in through the microscope. You would never, if you had an older microscope at home and it had a mirror, you would never want to direct that towards sunlight to travel through the microscope, because that could end up hurting your eyes. Once we're ready to use the microscope, there are two adjustment knobs that you have to use. The first one is called the coarse adjustment knob, and it's this larger knob right here. Sometimes on microscopes, those two knobs are together, but the larger one is the coarse adjustment knob, and then the smaller adjustment knob is the fine adjustment knob. The coarse adjustment knob, when you move that, the stage is going to really go up and down quite a bit. And then the fine adjustment knob, you see the image, but it's not exactly clear. So you're going to turn the fine adjustment knob just to get a sharper image. So those are the parts of the microscope, and we're going to go on and go forward and go towards the use of the microscope. So if you need to pause this, you're welcome to do that to fill in your parts of the microscope. This is not actually on your paper, but these are just some rules for using the microscope. I've really already said most of these rules, but we'll just read through them. Always carry a microscope with two hands, one on the base and one on the arm. Always place the microscope near the center of the table, not near the edge. Again, microscopes are expensive. You would not want anyone to pull that off by, running into the cord and pulling that down in the floor, because it could become damaged. Always begin with the low power lens. We'll talk about our objectives or our lenses there, but typically in compound light microscopes, you have three lenses. You have a low power, a medium power, and a high power. It's difficult to find an object on high power, so you would always start with low power when you're starting to use the microscope and starting to focus in on a particular image. Number 4, always watch from the side when you use the coarse adjustment knob. The coarse adjustment knob really moves the stage up and down quite a bit. So if you don't watch from the side, you could run the stage right into that high power objective, and it could actually break the lens. Number 5, always return the microscope to the low power lens when you're done. Again, that's to avoid damage. Number 6, always use lens paper to clean the microscope lenses. If you were to use one of these in class, you do have lens paper that you would be able to clean the lenses with. Otherwise, if you used your shirt or something other than lens paper, it could scratch the lenses. Number 7, never use the coarse adjustment knob with high power. Once you're on high power, you have found the object that you're looking at, and you don't need to find it. It's there. You just probably need to focus it better. So you would just use your fine adjustment knob. And then number 8 is really for older microscopes. If you have a microscope at home that uses a mirror instead of a light, you would never use direct sunlight for a light source. Okay, so on to our notes. When you're looking through the microscope, and I'll just go back and show you the microscope. When you're looking through the microscope, you're looking through your ocular, but you're also looking through one of these objectives. There are three different objectives here: a low power, a medium power, and a high power. So you are seeing things through one lens and then two lenses. So you're not just seeing it through one lens, but you're seeing it through two lenses. So when you're seeing that, it's the object is magnified not just through one lens but through two lenses. So there is something called the power of magnification. Power of magnification wants to know or indicates, what power am I seeing this at? How largely magnified has this object become? So remember, you are seeing it through two lenses, so you're going to multiply those two lens powers together. You'll multiply the eyepiece by the objective to get the power of magnification. So our next little chart goes through calculating the powers of magnification. Now, you don't necessarily have a microscope in front of you to look at, but in the laboratory, we have three different bands. We have a red band, a yellow band, and a blue band. These are small bands that are on the objectives or the lenses that you'll be looking through. The red power or the red band objective is the lowest power, and it has an objective power of 4. It magnifies things 4 times on its own. The yellow is the medium, and it magnifies 10 times, or magnifies things 10 times their size. And the blue power objective is the biggest one that we have. It is 40 times. On your laboratory that will be online today that you're going to do, your microscope lab that is online, it's a virtual lab. You will see on there that there's an oil immersion lens. We do have oil immersion lenses, but using oil gets a little bit messy. The oil immersion lens magnifies things 100 times its size. The eyepiece always has a magnification of 10, so we can just fill that in. So the eyepiece is always 10. So when you're calculating the power of magnification or the total magnification for the low power, 4 times 10 equals 40. So when you're looking at something on the low power, you get a total magnification of 40 times its size. The yellow is 10 times 10, that's 100. So when you're looking at something on the yellow banded or the middle or medium objective, it will be magnified 100 times its size. And then the blue objective, our biggest one that we're typically going to use, is 40 times 10, and so 400. When you're looking through that objective, things are magnified 40 times their size, which is pretty amazing. Number 4, what happens to our view of an image as you increase the power of magnification? So what ends up happening as you go through these bands here and you increase your power of magnification, you are seeing more detail, but you are looking at a smaller area of the slide. So a smaller area of the slide, but you're able to see more detail. Um, in just a second, once this video is done, you can click on the next video. The next video is me walking through using a microscope. That microscope is available to you in the library in our STEM lab. There's also a QR code above that microscope. You can scan that QR code and watch that video there as well. But that will let you walk through the use of the microscope. I hope one day, if you would, maybe talk to your teacher about it, if you're interested in using the microscope, hopefully one day you can go to the STEM lab and you can view that video and then use the microscope. But you can view that video today before you start your virtual lab. The very last question that you don't have 6 down here. But you do have question 5. It says, why can't you use the largest objective for some slides? Some slides, you can only, if the object is bigger, the object that you're looking at is a little bit bigger, um, you can focus that pretty well on the medium objective. If you use the largest objective, then as you go to rotate it in place, it may hit the slide, and then that may cause some damage. So I would say the largest objective cannot, be used for every slide that you're going to look at, because it may actually end up hitting the slide. So that's it for those notes. Let's see. I think there might be a few more things we can look at. These are just general notes for when you're focusing the microscope. I always teach it this way. You put the low power objective in place. You'll hear a click on your virtual lab in just a second. They'll talk about that click that you hear. That just lets you know that your objective is in place. You're going to lower the stage all the way down. You're going to place the slide under the clips and then raise your stage all the way up. Move the stage to the center of the slide, so make sure that slide is put in the center. And then when you're focusing, you're going to turn the stage down. That's typically away from your body. Use the fine adjustment knob for fine tuning, to sharpen that image that you're going to be seeing. And then once in focus on low, really all you have to do is switch to medium and then high, and use your fine adjustment knob only to get that safely in place. Okay, I think we're done with this portion. So you should have completed these microscope lab notes as we went through that little tutorial. So if you will go back to your home page, you can click on, again, Unit 1 here. And we are on day 5. You just completed these microscope notes, so make sure you submit that for a grade. And then click on 1.07, that is the virtual microscope lab. At the top, there is a link to take you to the virtual microscope lab, but I will go ahead and click on that and let you see that. But this is the document that you're going to complete as you go through and you do the microscope lab. So this microscope that you're using today is a compound light microscope. So if you click on that virtual lab, you're going to go here to using the microscope. You're going to click on continue.
Hello, lab assistant. Today, we'll view the gram-stained yogurt sample with a microscope to get an idea of the kind of bacteria contaminating it. To learn more about the purpose and techniques of gram staining, please take a look at the gram staining virtual lab.
Gram staining is a technique used for staining bacteria, but some hurtful bacteria will show up a different color than the harmless bacteria that you typically find in yogurt. And so companies like yogurt companies, they have to have quality control. So they'll take samples from their yogurt, and they'll do a gram stain on it. They'll stain it, look at it under a microscope, and make sure that they have no harmful bacteria growing in their yogurt. And if they find harmful bacteria, that leads to a recall sometimes of that yogurt. And so I'm sure you've heard on the news or on the radio sometimes that food gets recalled, and that's because of quality control that happens with these companies. So once you get to the lab, it'll walk you through everything. You're going to hit the continue button a lot.
We will use a light microscope with 10 times, 40 times, and 100 times lenses. The 100 times lens is an oil immersion lens.
Okay, so this microscope is a little bit different than the ones I use in class. Ours in class actually have four objectives. This one has 3, a 10, a 40, and a 100. Anytime you're doing this lab, if you want to click on a photo.
There are many different models and styles of microscope. This image shows one version of the immersion microscope.
So the photo there will just give you
We will use a light microscope with 10 times.
And then the info here.
Basic lab safety procedures. Before you start, there are basic safety procedures that need to be followed in all labs. Wash your hands before and after handling the materials. Wear gloves and
Okay, so I'm going to just turn her volume off just a second. So as you go through, you are answering these questions. Now, once you get to this portion, you have to fill in those lab safety procedures that she's just going over. So just make sure you sort of go back and forth so you don't miss anything. And you're looking at a stain, a culture, a slide of yogurt. And then you have to actually go and click on more information to get some of this extra information. And it'll tell you to click on the info tab if you need to, or to click on continue. But as you go through the lab, if you're ever stuck, you can click on the continue button, and that's going to take you to the next phase of that lab. But this lab is pretty good in the fact that it really just helps you feel like you are using the microscope. So that's it for today. Once you get that finished, you're going to fill in this particular paper as you go through, and you're using the microscope. Just make sure you stay on the virtual lab until you're finished all the way, and that will give you, the idea, the use of the microscope. I do want to point out to you. In a couple of days, once you advance through this program, you will have a test, a Unit 1 test. The microscope parts will be on that test. So I would just encourage you to start familiarizing yourself, getting used to these microscope parts because they will end up on your unit test. But once you're finished going through all the information, I will take you back to this particular part of your Canvas. So go to your home page, Scientific Method and Life. I will take you to the other video. So this is a video, like I said, that I did before. And this video just walks you through the usage of the microscope. And it's just 2 minutes. And it's really easy. And so that will just help you to understand. Today we're going to talk about how to use the microscope. The very first thing so that will just help you to understand how to use the microscope. Okie doke. So just you've completed your notes. Make sure you turn your notes in. You're going to watch this video on microscope usage. You're also going to walk through the virtual microscope, do that online lab, and complete your work as you do the online lab. And that's it for today. So I will see you guys next time, and let's go do some biology.